Have you ever heard of pulse modulation? It's not a term that we usually hear, but it's surrounding us. Let's start by understanding what a signal is. A signal can be described as any way of carrying information from one place to another. In daily life situations, signal is everywhere. A simple switching on or off the light represents a visual signal to be received by the eyes of human beings. Sound produced when talking causes air vibrations, which is also a sound signal. Turning a volume knob on a radio sends electrical signal to increase or decrease the volume of radio. Signals can broadly be classified as analog or digital. Analog signals are used in AM or FM radios and vinyl records. Digital signals occur in digital devices like phones and also some communication protocol like Wi-Fi. To send signals electronically, we often represent the information using short bursts of electricity called pulses. They are like tiny blinks or taps. To ease signal transmission, signals need to be modulated in the form of pulses. By changing specific parameters, different technique of pulse modulation can be done. Some of them are pulse amplitude modulation, which changes in amplitude, and pulse width modulation, which changes in duration or width of pulses. Let's talk about pulse amplitude modulation. Imagine when you clap, a larger sound can be produced when you clap stronger. Instead, a softer clap will produce a smaller sound. This situation works in pulse amplitude modulation. An instant of analog signal with higher amplitude is modulated into a discrete pulse with higher amplitude, and vice versa. One common application of pulse amplitude modulation is in communication fields, in which it acts as a modulation technique in signal transmission through Ethernet. Also, PAM is used in a LED driver for switching on and off the LEDs. Then, let's look into pulse width modulation. Imagine pressing a button fully but holding it longer for strong signals and shorter for weak signals. An instant of high amplitude signal can be modulated into a discrete pulse signal with wider width or duration, and vice versa. A wider width can also be defined as pulse signal with higher duty cycle. Pulse width modulation is widely used in motor speed control by controlling the average amplitude of voltage within a short period of time. Also, the same theory goes to throttle and fuel injector to control the output volume of the fuel by the fuel pump. Two differs between PAM and PWM. Let's compare both. PAM tends to have changes in pulse amplitude but fixed in pulse width to modulate pulse signals. But PWM tends to vary pulse width and maintain the pulse amplitude at the highest. Hence, PWM is more immune to noise than PAM, as noise is disturbing signals with other signals with uneven amplitude. These two modulation techniques have their own main usage field. PAM are widely used in communication systems, while PWM are mainly used in motor speed control and power electronics. Hope this video gives some understanding on pulse modulation to you. Thanks for watching.